On a sunny day in the month of May, when you step out of the house, you would say, "Oh, it's so hot today." But on the same day, you burned your hand while making tea because the water was hot. How would you differentiate the two hots that you have encountered on that day? Suppose you leave a hot cup of tea on the table. After some time, it cools down, that is, it turns cold. Now consider that you leave a bowl of ice cream on the table for some time. After a while, it loses its coldness or it turns hot. What is this magic that turns hot to cold and cold to hot? What exactly does hot and cold mean to us? When we take a closer look at the object, say the cup of tea, we will see that the tea is made up of a large number of small particles. These particles are under random motion. Particles in motion will possess a certain kinetic energy. The more the average kinetic energy of the object, the hotter it will be. This means that in a cup of tea, the kinetic energy of the particles is greater compared to that of a bowl of ice cream. So the term hot or cold is relative. How can this hotness of an object be measured? We can say that if an object is hot or not by touching it. But this will be a very vague measurement and it is not of much use to us in the scientific realm. This is where the term temperature comes into play. We have already seen that an object is said to be hotter when the average kinetic energy of the particles in the object is greater. Temperature is a measurable quantity that tells us a numerical value that represents the degree of hotness of a substance. Temperature of a system is a measure of the average kinetic energy of the particles that compose that system. Earlier, we had considered the example of the cup of hot tea when placed on a table for a considerable amount of time. It cools down. But how does this happen? And how can we explain this phenomenon? A hot cup of tea, from our earlier definition of temperature, has a higher temperature compared to its surroundings. When the cup of tea is left on the table for some time, it is losing its hotness, which means that some kind of energy flows out from the tea and into the surroundings. A region of higher temperature to a region of lower temperature. Similarly, when a cold ice cream is left out in the open, the ice cream is colder than the surroundings and begins to get hotter and melts due to the energy flow from the surroundings into the ice cream. This energy flow is called heat. Heat can be interpreted as a form of energy transferred between two or more systems or a system and its surroundings by virtue of the temperature difference between them. The particles of the hotter object have more kinetic energy. This means that they have the ability to do more work. The particles of the hotter body do work on the particles of the colder one. Heat can also be considered as the total work done by the particles of the hotter body on the colder body. And therefore, heat is measured in joules, just like any other form of energy. However, the temperature is measured using a different unit called kelvins. Now, it has already been said that the SI unit of temperature is Kelvin. But the question is, how is the temperature measured? I'll give you a hint. Using a thermometer is the wrong answer because a thermometer is just a device used to measure temperature. My question is way beyond that. How does the thermometer measure temperature? And that is what we will see next. So let's summarize what we have seen so far.
Manorama Horizon. Learning made simple.